Now we're done talking about general word problem strategies, and we can get into the particular question types. So the first question type we'll talk about are age questions. This category concerns people of different ages. What's tricky about these questions is that mathematical relationships can be specified at two different times. Right now, here's one relationship they have, and then so many years in the past or so many years in the future, here's another relationship they have. For example, right now Steve's age is half of Tom's age. In 8 years, twice Tom's age will be five more than 3 times Steve's age. How old is Tom right now? So what I'm going to say about this is the big mistake associated with this problem is thinking of the ages as a fixed number. People get very sloppy and they say, okay, well, S is Steve's age and T is Tom's age. Well, then that first equation, we can certainly say Steve's age is half of Tom's. S equals 1/2 T. We can say that. But for the second equation, we cannot just say, well, Tom's age will be 5 more than 3 times Steve's age. 2T equals 3S plus 5. We can't say that because in 8 years, the ages will be different. And we need to take that into account. It's not enough to say that T is Tom's age. We have to specify Tom's age when. So I'm going to say in most age problems, it usually makes sense to pick the variables to represent the age right now. Pick the age in the present moment. That usually is the best strategy. So for example, it's not that F is going to equal Frida's age. F is going to equal Frida's age right now. And then we use addition or subtraction to create expressions for ages at other times. So for example, F minus 5 would be Frida's age 5 years ago. F plus 7 would be Frida's age 7 years from now. We can create other ages based on the age now. We will use these expressions to create equations that correspond to statements about age relationships in the past or the future. So if we have in 7 years, Edgar will be twice as old as Frida, well, suppose we picked E as Edgar's age now, and F as Frida's age now. Well, in 7 years, Edgar will be E plus 7, and Frida will be F plus 7. So E plus 7 will be equals twice 2 times F plus 7. And that's our actual equation. So having seen that, think about this practice problem. You can pause the video and then we'll talk about this. Okay. Right now, Steve's age is half of Tom's age. In 8 years, twice Tom's age will be 5 more than 3 times Steve's age. How old is Tom right now? Well, first thing I'm going to say, T is going to be Tom's age now. S is going to be Steve's age now. And I could write it as S equals 1/2 T, but I think it makes more sense to write it as T equals 2S. That way I don't have to think about fractions. Now for the other ages, I'm going to have to use T plus 8 and S plus 8. So twice Tom's age, 2 times T plus 8, will be equals 5 more than, so we're going to add 5, 3 times Steve's age. 3 times Steve's age is S plus 8. So we get this equation, 2 times T plus 8 equals 3 times S plus 8, and that quantity plus 5. Well, so that I don't have to worry about fractions at all, I'm just going to plug in for T. I realize that I'm not solving for my target value. I'll have to go back and find T later on, but that's fine because I can avoid fractions by doing it this way. So I just plug that in for T. Now I have an equation in S, multiply everything out, get everything all collected, and we get S equals 13. So that is Steve's age right now, and that's half of Tom's age, so Tom must be 26. In summary, age questions can be tricky when different mathematical relationships among the ages are specified at different times. And so we have to be very clear in defining the variables. It's not enough to say that F is Frank's age. We have to specify when. F is Frank's age now. We have to be very clear on that. Choose variables to represent the ages now, and then use addition or subtraction to create expressions for ages at other times.